This video will present solutions to the VCE 2023 Mathematical Methods Written Examination 2, Section B, Question 2. This question concerns a rotating observation wheel. The key information about this wheel is that it rotates once every 30 minutes. It has a radius of 60 metres and its lowest point is 15 metres above the ground. In Part A, we have to justify the b and c values that we've been given for h of t, the cosine model for the height of pod A after t minutes. The b value will be equal to 2 pi divided by the period of the model, which is 30 minutes, so it is 2 pi over 30 or pi over 15. The c value is equal to the height of the principal axis, which is the height of point P, which is 15 metres, plus the radius of 60 metres, and so c equals 75. Before I do part B, I'm going to define h of t on my ClassPad, although I'm going to use x in place of t to save me trips to the variable keyboard. First, I'll enter the function's expression, using the negative key to start me off. And then I'll swipe, and from interactive choose define, naming my function as h. That done, it is time to find the average value of this height function as the pod moves from point A to point B. This will take 7.5 minutes, as this represents a quarter of the 30-minute revolution. So the average height will be the definite integral of h of t from 0 to 7.5 divided by 7.5. This can be calculated using the definite integral template on the Math 2 keyboard. Once the definite integral is entered, to divide it by 7.5, I'm going to swipe it, tap the fraction icon and pop in the required denominator. To get that answer to 2 decimal places, tap the exact output, then tap the fraction to decimal key. Part C asks for the average rate of change of height, which sounds a bit like Part B, but it is in fact a quite different thing to calculate. Whilst my ClassPad has an average rate of change user-defined function, I don't really need it here. We know that the change in height between points A and B is 60 metres, the radius of the wheel, and we know it takes 7.5 minutes to travel from A to B. So the change in height divided by the change in time is 60 divided by 7.5, which is 8 metres per minute. Part D turns our cosine model into a piecewise model, telling us that after 15 minutes, half a revolution, the wheel is stationary for 5 minutes. It then continues to revolve at twice its original speed for the next 7.5 minutes, completing the second half of the revolution. Before I tackle parts 1 and 2 of Part D, I'm going to jump ahead and sketch the graph of this in Part 3, as I think it might help my thinking about parts 1 and 2. The height starts at 15 metres, and the first 15 minutes equates to half a revolution, meaning that the height of A reaches its highest point of 135 metres after 15 minutes. This part of the graph should look like half a period of the cosine curve, the going up half. For the next 5 minutes, the wheel is stationary, so the graph is horizontal from t equals 15 to t equals 20. The third section of our graph is a descent from a height of 135 down to a height of 15, that takes from time t equals 20 to time t equals 27.5 minutes. This section also looks like half of a period of a cosine curve, the going down half, but it is dilated horizontally by a factor of a half, as the wheel is rotating twice as quickly. With that done, let's go back to Part D, Part 1. As k is the function for the horizontal section of the graph when the height is constant at 135 metres, then k equals 135. Looking at the third part of the piecewise function, the values of m and n transform our height function, with m dilating horizontally and n translating horizontally. As the dilation is by a factor of a half, corresponding to the wheel travelling twice as fast, then m equals 2. Part D, Part 2 asks us to find all the values of n. One way to do this is to use a known point on this part of the curve, like the endpoint 27.5, 15, and sub it into the rule so we can solve for n. This looks like h of 2 times 27.5 plus n equals 15. We can solve this for n using inverse operations or by using our ClassPad. Via interactive equation and solve, with the variable set to n. This output is the ClassPad's way of saying that n equals minus 55 plus some integer multiple of 30, the period of the height function. We can write this as n equals minus 55 plus 30k, where k is an element of the set of integers.